CEO of Newell Recycling Equipment, LLC. He has owned and operated numerous companies involving and with recycling. He has also been involved with the national and international recycling associations and has been a board member and chairman of various committees for most of his long career. During that time, he has delivered more than 100 technical papers on recycling metals. In 2015, ISRI, now ReMA, the Recycling Materials Association, awarded Scott a Lifetime Achievement Award, and in 2024, Who's Who of America also awarded him with the Lifetime Achievement Award. So, Scott, it's all yours.
Thank you. Hi. I'm Scott Newell. I've been doing this now for a long time, something more than 70 years, and it's been an interesting and rewarding lifetime journey from a small town junk dealer in Kennedy, Texas. I know it kind of relate to some of the previous discussions. But being a junk dealer was not the most prestigious thing, so we started trying to look for other words. We said we're in the salvage business and secondary resource engineers, and finally today, since recycling has gotten to have a better name, I'm happy to be considered a recycling expert. Funny thing happened to me last week at the Cary convention. Here I am speaking about urban mining, and I was given my name tag, and it said untapped sources, but then the ribbon that goes around your neck said urban mining. So I thought, I'm happy to see that other people also understand that a mine in the city and urban area is a mine for those of us in the recycling industry. So my father started, as I said again, with 1938 with a small town junkyard, and fortunately he was smart. Good. He didn't finish high school, but he did actually wind up with 2 honorary doctorate degrees. So it was kind of a hard path to follow, but we were in a small town junkyard, and my father was dismantling automobiles, and after he sold all the parts, he had a lot of steel left over that you didn't know what to do with. You couldn't really get rid of it. And so he built a portable baling press and started baling it. And pretty soon the baling business got to be better than the parts business, and so he was doing more and more of that. And we eventually wound up with 5 operating plants. And of course then we handled the non-ferrous at warehouse by hand. But in 1960, it was a little bit later than that, it was 1961, I think, we found out that copper mines were using shredded tin cans in a leach precipitation process. That means that they were taking tin cans, shredding them, and they would put them into like a swimming pool. Then they would take sulfuric acid and put on a copper ore body and take that solution, and you get copper sulfate, which went into the leach precipitation bin with the shredded tin cans. The copper ion and the iron ion would change places. You would get iron sulfate in solution and free copper. And so that turned out to be a pretty big business. Well, one day I was in a copper mine buying some scrap, and I talked to a guy named Al Stovall, who's a Bluebird copper mine. And I said, hey, you know what? We're selling tin cans, we're buying them, but we're not shredding them. And I said, would you buy some from me? And he finally said, yeah, if you guarantee me 400 tons a month, I would buy shredded cans from you. So I called my father and said, Dad, we can do this. Can we shred them? And lucky for me, he was able to invent a small shredder. So then we started selling more and more and more cans, and so we needed more and more material, so we kept building bigger and bigger shredders, and so we could produce more tons. finally we discovered that shredding heavier material could be used in an electric arc furnace. And so we built a shredder that was big enough to shred that kind of material. Well, I realized that I should have put a paragraph in here that said, why shred? Well, we shred things to make small, similar-sized pieces where we can separate the parts. If you shred an automobile, you get all kinds of people, like its tires and seats and aluminum and copper and steel. And if you hit in similar-sized pieces, you can separate them. That's why we shred, and you'll see a little bit more of that later in the program. Well, this machine that my father did was so good, we were able to patent it. And we were operating 5 plants, and other people started coming to us and saying, hey, wow, that looks pretty good. I mean, you're making money. Would you make one of those for me? So eventually we started manufacturing. And fortunately, we've had a lot of good success. In the world today, these shredding machines are the big ones, sell between $5 million and $20 million, and there's 1,229 of them in the world at the moment, and more than half of them have the Newell name on them. So I'm very proud of that. So this is what a shredder looks like. My father's patent was limited feed, top and bottom discharge, so that you can get good separation of material. It was successful enough that the American Society of Mechanical Engineers awarded us in 1994 National Historical Engineering Landmark. And I'm proud of that one too. So, as I say, it's always good to understand where the speaker is coming from, so thank you for letting me share all of that. So you know I'm coming from a lifetime of doing the same thing, shredding, recycling, separating. Back in 1971 in San Antonio, there was a big movement to beautify the world, to beautify San Antonio. And they were making it so difficult to buy and disassemble automobiles. Nobody wanted to see a junk car. And they made the regulations and rules were difficult. So I took the brave step of asking to make a presentation. So I went to the Beautify San Antonio Committee in 1971, and I gave them a speech. And in that speech, I told them that about how much material was being generated, how much waste material was being generated in the world, how much waste was being generated in San Antonio. And then I told them what Newell was doing in terms of recycling percentages of that waste. So I was very happy that the next year after that, they gave me an award that said we were the best company in San Antonio regarding making Beautify San Antonio. That caused me to start thinking in terms of the urban area being like a mine. And so Thor Heidel, a famous oceanographer who did the Kon-Tiki project where he floated on a yacht across the Pacific, he one time said that the Earth is like a spaceship hurtling through space without an exhaust pipe. Everything that we create, everything we use, has to be used. There's nowhere to dispose of it. So that started me thinking about recycling. Recycling has gotten to be very popular these days. Why? Well, it's more efficient than mining. It requires substantially less energy, and metals can be recycled indefinitely, and it solves a disposal problem. So now I want to compare with you, in the urban mining analogy, the difference between mining ore bodies and what we do recycling in the city, for example. The first topic would be copper. Copper's been used by humans for about 10,000 years. It's one of the few metals that can be found in nature in a solid clump. However, we've been mining for a long time, And a modern copper mine, the average copper content is less than 0.6%. So compare that to, in the urban mine, we have electric motors and we have starters, generators, and other pieces of items like that. And this pile is about 20% copper and about 5% aluminum and 75% steel. So I think that's a pretty good urban mine when you identify it that way. This is a hand-picked material from a shredding plant where the people would pick up, when you shred it and magnetically separate it, sometimes the copper is still wrapped up in steel, and so it's hand-picked. Now this material has about 28% copper and 4% aluminum and about 68% steel. One of the things we've done, shredding, making small pieces, we take those piles of copper bearing material, we call it, and we break them into very small pieces. And when we make the very small pieces, then we can separate them. And in this, for example, this is a typical kind of a shredder we call red shred, and we can put material in and we break it into small pieces. This is a kind of a plant, and in this plant there's a shredder that's separating material. It's shredding it, and then from that we go to a separator with magnets, and then the non-magnetic portion goes to an eddy current, which would separate aluminum from the other non-magnetic material. About 25 million tons of copper is used every year, and 8.7 million tons of that is recycled. In the UK, in London, we visited there not so long ago. This is a Newell shredder, and it's working on processing electric motors and other kinds of electronic scrap. And it's separated then as, this is the kind of incoming material that you're looking at. It's got all kinds of copper and stuff mixed in it. And then it gets separated into these kind of products. This is the copper contents from this. Then we have the steel, which is shredded into very small pieces so that we can separate the copper from it. And then this is the shredded aluminum. So we're mining again in an urban setting. The copper that has been produced there is still not 100% copper, so we typically are grinding that again to a smaller material, and then we're making further separations of like-sized material, because we can separate by gravity, we separate in a lot of different ways at that point, so we can make a better copper product. Switch over to aluminum. Aluminum is not found in the pure form in nature. It comes from bauxite, which is 30 to 60% aluminum oxide. And aluminum is the second most highly recycled metals in the world. It's about 30 million tons of aluminum gets recycled every year. The interesting thing to note is that it takes 7 times more energy to produce aluminum from the bauxite than it does in the recycling. So in some sense, this is green in terms of less energy and more efficient production. It costs a lot less to recycle aluminum than it does to make it out of bauxite. Aluminum is in our daily lives. You see it, it's in the urban mine all the time. You find it in consumer goods, machinery, electrical. And so that's why we deal with it every day. It's one of those things that's going to be in our society, and we deal with it, and it's a good thing to do. Recycling aluminum from the urban mine. This is a plant that we supplied in China, and this is the world's largest secondary aluminum processing company. And we shred this incoming material into similar sized particles so that we can make the separations, and then he can make it back into aluminum ingot, which gets made back into aluminum products. there's a lot of aluminum in the world which we don't normally just think about or recognize. In this particular case, we have a big pile of engine blocks. And these engine blocks have a lot of aluminum in them along with copper. But in today's modern engines, we have about 70% aluminum and 30% iron and steel. Another picture of cast aluminum being ready to shred. This is what the aluminum looks like after it's shredded. It's been separated, and it's a good cleaning product. And then you can see we make it in two sizes. We have plus sizes and minus sizes because we have to treat the separation systems differently. So this is a typical look of what 5mm aluminum granules look like. This is at a plant where we just ran a process. We ran 200 tons of post-consumer aluminum. That means like lawn chairs. It means like aluminum frames on the window. It means aluminum that you get from appliances and from automobiles. And when we did that, this is a product which is 98+% aluminum, which meets the definition of our industry. It's called Twitch, which is a high-grade secondary aluminum product. So this is another pile of material. This was just recently in Greece, and these are baled used beverage cans, UBC we call them. And then this is a known alloy of aluminum. And in this plant, they buy a lot of aluminum bales, cans, UBC, and then they process them back into cans. These are the ingots that they're making out of the UBC, and they'll ship this to a company that's making aluminum cans. Some of the smaller ingots, these are big castings, which the same thing, the 3000 and 5000 series of aluminum. And so these big slabs are easily to transport, and they go back to manufacturers who are making new products. You can only do that with aluminum and other products if you have a very specific separated alloy of material. If you mix that, if you melt that material that you saw from the shredder operation, it's not going to be a known specific alloy. It's going to be a mixture. And so that then has to be put into a different type of a furnace and a different type of melting and a different uses for that in the future. That material has to be analyzed, and it has to be either blended with some virgin aluminum to make the right kind of products. But today we're working very hard on separating the recycled aluminum by specific alloy so that it can go directly back into new products. Now I'm going to switch over to iron and steel. Iron ore deposits. Typically we have between 25 and 60% Fe, but as we all know, it takes considerable amount of effort, time, energy, equipment in order to mine that material and make it into new steel. Again, it's analogous to the aluminum. It takes about 7 times more energy to make a piece of Fe from iron ore as it does from recycling. So again, it's more economical, more environmentally friendly, and I think that there's a big pressure on us in the world to always be doing the recycling. The world steel we do about 1.6 billion tons of new steel every year, and about 500,000 tons of that is recycled. In the United States, we have about 80 million tons of recyclable steel, and I'm happy to say about 62% of that is now shredded, because shredded is a very efficient way to do the recycling. I threw in a couple pictures like this so that people who aren't familiar with this big recycling effort on steel would understand a little bit more about what it takes to do it. This is in China at one of our big shredders. So every morning, trucks would show up with this material that would be headed for the shredder. You can see in China, where labor is pretty cheap, this is a truckload of recyclable steel that's been hand packed into the truck. You cannot make that kind of a stack with a crane. And so I kind of thought that was interesting. And over here you can see background, just thousands and thousands of tons of material. And material that's ready to be processed. Again, more piles of material ready to be shredded. And then in the shredder itself, in the biggest shredders we make today, we guarantee 400 tons an hour of output material, which is pretty good. But when you handle 400 tons an hour out, then the separation systems, as you can see, we have to split the lines so that we can make effective separation. Back in China, this is in Suzhou. It's a 10,000 horsepower shredder, and in order to move that much material, it takes a lot of handling. You've got to capture the material from a big distance. You got to get it to the machine. Now to get it into the machine, you got to pick it up, put it on the in-feed conveyor. So you can see just about how there's many cranes that are feeding the machine. Once the material is shredded, again, it needs to be separated. And here we have air separations, we have magnetic separations, and we have, then after that, we get into some further separations. I like this picture because I took this picture in Zhejiang, which is 11,000 horsepower shredder, one of the biggest ones we ever made. And we guaranteed 400 tons an hour, but at this moment we were running 600 tons an hour. And this is what 600 tons an hour of shredded material, steel, looks like. I often tell the story with this one is that when I was running the number 2 shredder, the Newell shredder in Phoenix, Arizona, I had 408 horsepower on my shredder, and I was doing about 6 tons an hour, and that meant that in the course of a month I could do around 600 tons in a month. And I ran the shredder here one night, and when I saw that calculator on the computer screen, it said you just did 600 tons. I thought, wow, I just did in 1 hour 600 tons, which is what I used to do in 1 month of hard work. So it was kind of that's why this picture reminds me of that. We have a number of shredders at steel mills in China. More than half of all the shredding capacity in the great country of China is in our machines. And a lot of those are at steel mills. 23 of those machines can produce 1 million tons per year or more, which is a lot of recycling. We're just now getting to those larger type machines in the United States and Europe, because the catchment area for getting that material to the machine is not so easy. But we're finding that because the economics are so attractive, that a lot more people are interested in doing it this way. So we can see that we can, the sustainable construction of material and strength is much more economical, it's efficient. And this is kind of the interesting point here, is that every ton of recycled material saves about 2,000 to 5,000 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. And steel can be recycled continuously, over and over, made into products without any loss of quality. So this makes it the one really true cradle-to-cradle type building material. This is just a sketch of a very modern shredding plant. It's a $20 million investment, and this machine will do about 100 tons an hour of steel, and that means 30 tons an hour of ASR, which we were talking about earlier today, goes to a separating system where it's separated by air, it's separated by size, it's separated with eddy currents, it's separated with very strong magnets, it's separated also then with high frequency eddy currents, which will process different types of material. We're working on now identification of the alloys of some of the products like the aluminum. We want to separate the 63 series out of the aluminum so that that can be directly reused. So it's easy to understand the value of recycling when we understand the amount of recyclable material that reaches the end of its life in one form and can be converted to another form. And it can be done with a lot of savings of energy, CO2, and of course, money. So this does indeed make our towns and cities very much like urban mines. And so I predict that recycling will continue to grow in popularity. And I was encouraged by the previous speaker's comment that said that if you're in the recycling industry, there's going to be a push toward getting investments to that industry because it's good for us, okay? So, thank you very much. If you're interested in any of these other things, we have a lot of the technical papers telling how these things happen on our website. So you're welcome to just to go there and download anything you want to. Thank you very much.